Hi, I'm Alan Ross. I'm the managing editor of APC Media and APC Technologies. We are at the CGRE 2023 Grid of the Future Symposium. And these interviews are with the leaders at CGRE and the leaders of the industry. Hope you enjoy. My next guest is Cheryl. It's Maletich, right?
Maletich.
Maletich. I was trying to get it right, but anyway. Cheryl is the Senior Vice President of T&D at ComEd. Have I got it right?
Transmission Substations.
Oh, I thought it was T&D, the whole thing.
Yeah,
Transmission Substation. Same thing to me. Same thing.
It's the big stuff. All the big stuff.
Yeah, the big stuff. So before we get into talking about that, I want to talk about how did you first get into engineering?
Mm-hmm.
You are a double E, right?
I am.
And at some point in time, you said, I'm going to go into power engineering because it's engineering, then it's power engineering. How did you do that?
So I am the youngest of five. I have two brothers and two sisters.
Okay.
Both of my brothers are engineers.
Okay.
One's a chemical, one's a structural.
Okay.
I ended up becoming electrical.
That's amazing for the family.
Amazing, right?
Yeah.
And neither one of my sisters went to college, so I was the only girl in the family that went to college. And, for me, I had a lot of positive influences, growing up.
Yeah.
I loved math and science growing up.
Oh, okay.
So it was kind of a natural fit. And, my father was a tinkerer. He loved doing things around the house, fixing things around the house. And I would, as a little kid, I'd follow him around the house. And I got really interested in how things work, how to fix things.
Yeah.
And so at a young age, I learned how to use tools and, how to do different things around the house. And that really was what sparked my interest in engineering. And as I was, growing up, I had a natural affinity for math and science. It became easy for me in school, all the way from grammar school and high school. And so I decided I wanted to go into, electrical engineering in the early 90s. And even back then, there weren't a lot of women in my classes. I graduated from University of Illinois in Chicago. So large school, large campus, large classes. And, I'd be in a classroom with 100, 150 people, and there'd be maybe 4 or 5 women.
Yeah.
So I was interested.
I went to Georgia Tech, and it was the same thing. It was very unique to see women in your classes. And now you go to Georgia Tech, and literally it's almost half, and you're going, wow, we've come a long way in a very short period of time.
Yeah.
So you get into power engineering. You obviously has had like 10 companies you've worked for between now and then, right?
No.
One company, ComEd. Tell me about that.
So,
and your career track.
So, it was really interesting. At that point at ComEd, they were in like a hiring frenzy.
Okay.
I hired like 500 engineers over like a 3-year period. So it was great. When I graduated, it was very lucrative. And I started out just as a distribution engineer. So I was, moving services for poles and, redesigning distribution circuits for facility relocates and, things like that when I first started with the company. And, I really loved being in engineering. I loved talking to customers and doing things like that. But I really wanted to try and, put my hat in the ring for a supervisor after a couple of years. So I had tried, bidding on a couple supervisor jobs, wasn't really getting anywhere, got a little frustrated early in my career. And I had a mentor at the time, and he was in the supply organization. And he's like, well, why don't you go over and work in supply for a little while? I'm like, oh, but that would be kind of interesting. So I actually went over, and they say never work for your mentor, right? But I did. And it was one of the best experiences I had in my career. Because I had been working on distribution systems. I had done some planning of I did distribution planning, so I planned distribution system. And then I went into this world where all of a sudden I'm negotiating contracts, right? And I'm buying power transformers and communication equipment. And that's really when I was introduced more to the transmission substation part of the world.
Yeah.
And, that's a great place to learn because vendors love to talk to you and tell you all about their equipment, right?
Oh, yeah.
So it was a great place for me to learn how the equipment worked and, how we use different things. And it was, I would say one of the two points in my career that were some of the defining moments in my career where I really felt like I was in a totally different area, totally out of my comfort zone, and I learned a ton.
It's interesting. Just I'll focus on the transformer part of it. In order to purchase a transformer, you have to specify, right? In order to specify, you have to know what you're specifying to. So, and then when you put the specs together, then you have the bids, and you got different ben. I mean, it is buying one transformer. You learn a whole heck of a lot. Buying a lot of transformers for different things you learn. So I think that would be true of the entire supply chain in doing that, the asset.
Well, and then you think about then trying to get that piece of equipment from overseas to the States. And you learn a lot about, icing conditions and wind currents and all kinds of things to even to get the...
And you did an SFRA of the plant, but you did an SFRA when it landed, and it's different.
Exactly.
Are you sending it back?
Right. What do you do?
We have a lot of decisions. So then you move from that into substations. Go ahead.
So then I went and went in and started managing. So I stayed in supply for a little while. I was in procurement, and then I actually managed some of the storerooms in supply for a while, which was another interesting experience. And then I decided I wanted to kind of go back into the engineering side. I was a manager of capacity planning for a little bit. And then I was like at another junction in my career where I want to do something different. So I was about halfway through my career, and I was like, no, I really like the distribution control center. And I had an opportunity, moved over into the distribution control center, and just fell in love with operations.
Okay.
And for the second half of my career, it's all been around operations. And really, for me, it's funny. I had my prior CEO used to call me an adrenaline junkie because, when disasters happen, that's like when I was on it, right? We were here, we were right in the middle of everything, right? But it was I think it was a second point in my career where I really pivoted to something different, something I knew a lot about, but not a lot, and really helped me grow in my career.
Yeah.
And I moved up, and that was actually, I became the first vice president of distribution system operations. I was the first woman for that role at ComEd, which was kind of interesting, which was very interesting. Well, loved the job. It was so much fun. Little draining.
Yeah.
That is a 24/7 job.
Yeah.
Really did a lot across the industry with emergency preparedness and learning from others and, trying to get better, which was really, really amazing. And then about 4 years ago, I had the opportunity to move into my current role as a senior VP of transmission and substation. And this role, I kind of had the best of both worlds. So I have engineers, so I get to geek out with my engineers, right? But I also have construction and operations. So I still have that operations piece under me as well. Yeah. So it really is it's a fun job.
So you've had these things where you go and you love that, and then you go and you love that, and now you are where you love that. That seldom happens in a career. Most times it's like, I had to pay my price for 10 years here in order to get where I love. But congratulations on that. Switch gears now. I'm going to tap into your expertise.
Okay.
So we had a grid for decades that was you generate large generation, whether it was coal, I even consider gas large generation, very controllable.
Right.
Pipelines called transmission, and it's just how big do you build the pipeline for demand down here at distribution, right? And now we have a world that changed because you have generation at the distribution end.
Right.
You've got all of these variables, and here we are at Grid of the Future, C-Grade, and we're being asked to create a flexible, hardened, modern, resilient, reliable grid. I mean, it's like, oh, by the way, take all of these variables and make it better. And it's hard. It's hard to do. So we got a lot of challenges. Where do you think some of the greatest challenges are lying within that whole? I mean, it can be in your area of expertise, but you've seen every area. Where do you think the greatest challenges are?
It's really interesting. So in the state of Illinois, 2 years ago, they passed the Clean Energy Jobs Act. So, the state has very specific goals of where they want to be by 2050. And so we're looking at, well, how do we help make sure we not only support it, but we're also prepared for it. I mean, we're talking 1 million electric vehicles by 2030, just in the northern part of Illinois in our service territory. We're nothing close to that today. Right?
Yeah.
So how do we make sure we're preparing the grid for that? Not only the load, right, but also the changing customer expectation.
Right.
Right? I mean, people have to charge their cars, and you have a major storm that comes through and people are out of power for 3 or 4 days, that's going to be a problem, right? So how do we do different things, innovate differently, and look at the grid from a different perspective than we ever had before? I think our other biggest challenge, people talk about climate change a lot, and storms are a big part of that. But one of the things, we actually partnered with Argonne National Lab, and the way our weather is going to be in the state of Illinois is going to change over like the next 30 years. We're going to be more like Missouri than Illinois. So it's going to get
You're having
warmer.
hurricanes now.
Well, it's going to get warmer, right? It's going to get warmer. So when you think about, so our load profiles are going to change because of the climate change. We're going to have a lot of additional load through electrification, decarbonization, and there's a lot of factors that are all coming together. And how do we really start to plan for that? So we're looking at, how do we look at the equipment that we're buying today differently so we're prepared for what the grid's going to look like in 10 years, 20 years from now? And it's a challenge because nobody has all the answers. And one of the great things about this conference is you hear from experts all across the world.
Yeah.
What are different people doing? Like, so what different innovations can we think about and steal from others, right? Because you can't innovate everything yourself and try everything yourself. But what can you determine that really works for maybe some other utilities that you can start to actually move into your utility?
Is there something that you have seen, and it can be something you're involved in or something that's in another department, that kind of epitomizes the ability to adapt, to change, to adapt within ComEd, or actually that you've learned here at the conference, but I'd particularly like you to focus on ComEd, that you can say, wow, we haven't got all the answers, but we certainly have nailed that one.
I think there's a couple of things. The one thing that I love about our company is we are allowed to try different pilots and different things. Yeah. So we have a microgrid, right? We put a microgrid in 5 years ago. And, it really was trying to understand, well, how does that really integrate into our grid? And we actually tied it to an existing microgrid at Illinois Institute of Technology to see, well, what happens when you tie two microgrids together? Okay. How is that going to work, right? We do a lot of partnerships with the DOE. So we have a smart grid area that's under our distribution engineering, and they really do look at different innovations on how we can look at technology differently. We actually have a superconductor in one of my substations in Chicago. So it's the only working superconductor in the United States. And, it really, we put it just in a substation between two terminals, really to pilot it and see how it works and test the technology. Yeah. Because when you think about, especially in urban areas like the city of Chicago, land is a premium, right? And being able to build a new substation in downtown Chicago, that's going to be a little hard, a little challenging, right? So what other types of technology can we use so that we can benefit from load that we may have in other areas and help kind of move through the distribution system?
Last question, you alluded to it already, but I want you to go back to value of C-grade to you personally and to the organization, to ComEd. But you alluded to it, but do a commercial for C-grade.
All right. I will say that C-grade is very different from a lot of other industries. A lot of people that are here are also involved in IEEE, right?
As I am.
And IEEE is a lot of academia, typically, right? The one thing I love about C-grade is that you really do have the people that are boots on the ground in the utilities that are trying different things, partnering with different people, and the fact that it's all across the world, and you partner, and the working groups have people all across the world. So it's not like, well, this working group is just the United States. So you're getting perspective from different areas, because I think there's a lot that we can learn in the United States from Europe.
Yeah.
They do things a lot differently. And, when you start talking to people, it's like, oh, I never really thought about that.
Yeah.
Really? You have that? That actually works on your system? Right. So I think that's really the value of Seagrey.
And I know Australia has done some pretty amazing things with their grid. So all these things we talk about, hardening, resiliency,
Right.
I mean, they are probably more advanced than we are.
Sure.
We can certainly learn from them and make sure they're on the working groups. I'd go recruit Australians to
There
be
you
part of
go.
everything like that. But you were involved with Seagrey in a voluntary role, correct?
So I'm actually on the executive committee.
Okay. Well, here's an interesting thing. I need your permission,
Okay.
but I also need the permission of everybody else on the executive committee. We were originally going to publish these in take the interview, transcribe it. We published the video part in a whole, right? But we were going to transcribe it and publish it in different magazines over the course of the next year. I create the themes of the magazines, and for the life of me, I can't remember what they are right now. But this would probably go in something that related to Substation, like there. What I want to do, and it's with Seagrey's permission, I'm going to take all of these interviews and we're going to publish a special edition, Seagrey US, and just publish these interviews. That's it. No ads, no nothing, no technical articles.
Okay.
And I didn't think it'll be something that Seagrey will be proud of. It'll be a great recruiting tool for Seagrey, and it'll probably tick IEEE odds because we haven't done it for them, but these interviews have been fascinating. So thank you for being part of it. You'll hear that. I've already talked to a couple of other people. Chris Root says, yes, we're doing it. And I said, Chris, let the executive committee decide. So
There you go.
he's there. All
I
right.
have my vote.
You got your, that's right. So it's him, you, John McDonald, a couple other people.
There you go.
All right, we'll get it. Thank you so much. It's been great, Cheryl.